to folder. Hey, welcome Algebra 2. Today we are going to learn how do you tell the difference between a linear function, an exponential function, and a quadratic function. So the first thing that you should know is that a linear function is always in the form y equals mx plus b. And so the b is going to represent your starting value. And on a graph, that will show up as the y-intercept. The m is going to be your slope or your rate of change. If m is a positive number, then that means that something is going up over time. And if m is a negative number, that means that you know that it is going to be decreasing or going down over time. So we're going to look and we're going to use this graph right here. And we are going to create a table of values that corresponds to this equation or to this graph. All right, so when x is 0, what is the corresponding y value? It is 2, good. When x is 1, what is the y value? 5, good. All right, so A, you can plug it in right there. On some of them, you might be able to follow your graph up. When x is 2, what is your y value? 8. When x is 3, what is your y value? Should have 11. And finally, when x is 4, what is your y value? 14, good. So what is going to happen on your test, and very possibly the SAT, is that you won't be given any of this information. You will only be given a table of values, and you will have to know, gosh, what do I look at to know whether this is a linear function or an exponential function? So what we do is we look at how the y values change. So when I go from 2 to 5, how do I get there? Can you describe it by saying I add, subtract, multiply, or divide, and then a specific number? How? Add 3. You want to see if this pattern stays consistent throughout. So to go from 5 to 8, how would you get there? Plus 3 again. Can I still get from 8 to 11 by plus 3? Yeah. And from 11 to 14, I can get there by plus 3. So if you are looking at a table of values and you find that you can go from one y value to the next by addition or subtraction, that is how you can say this is a linear function. I can get here by addition or subtraction. The exponential functions we have not had a great deal of exposure to, but we will a little bit in this unit, and a lot in a future unit. For an exponential, it has the form y equals a times b to the x. And in an exponential function, the a is your starting value. And the b is what I would refer to as the base or the multiplier. P-O-I-E-R. I think I did that right. So on this exponential function right here, and in case you can't read that, that says y equals 2 to the x. So this seems to be going up over time. So this is what we would refer to as a growth function. You can tell if something is a growth function or a decay function by looking at what the b value is right there. So I can tell that 2 is the b because it is the number that has the exponent onto it. If b is greater than 1, then you know that you will have a growth function. That is a greater than symbol right there. That says b greater than 1 equals growth. If your b value is between 0 and 1, essentially, you will have a decay function. All right, so we are going to make a table of values and see if we can figure out what does an exponential look like on a table of values. Nope, we're starting with -2, by the way. All right, so when x is -2, you're like, I don't know what number that is. That's super small. But you should be able to put that into your calculator. So in your calculator, put in 2 to the exponent of -2, please. And then I would love your answer as a fraction.
You said 2 to the -2?
I did, yep. 2 to the -2 power. Good. 1/4. Now what is it when x is -1? So in your calculator, put in 2 to the -1. And if you switch that to a fraction, you should have gotten 1/2. 2 to the 0. This is a fun fact that everyone needs to know. Any number raised to the 0 power is always what?
0.
No thanks. It is always 1. Anything to the power of 0 is always 1. The next two you should not need your calculator for. When x is 1, what's 2 to the first? 2. And when x is 2, what's 2 to the second? 4. All right. So if you only have a table of values and you're trying to figure out what kind of function is this, linear, exponential, or quadratic, you always start by looking at your y values and going, how did that y value go from 1/4 to 1/2? Sometimes when it's fractions, it's a little bit harder. See if you can find a pattern. How can I go from 1/2 to 1? How can I go from 1 to 2? Have you found the number can I add, subtract, multiply, or divide by a certain number over every single interval here to get to the next number? Okay. What about from 2 to 4? How can I get from 2 to 4? I can go times 2, okay? So let's see if I backtrack. If you go 1 times 2, does that equal 2? So can you multiply by 2 to get to the next number? Yes, okay. What about going from a half to 1? What do you get when you go a half times 2? It is also 1. So my pattern is I am going multiply by 2 across every single interval to get me to the next number. So if your pattern is that you have to multiply or divide to get to the next value, then that means that you have an exponential function here. The next one is quadratic. We put that in here. In standard form, we're looking at y equals ax squared plus bx plus c. We've touched on quadratic a couple months ago. In standard form, you all are supposed to know what the c is. Where does the c show up on a graph? That is the y-intercept. And how are you going to know? I don't know, because there's an x squared term. I don't have a ton to say about the quadratic. All right, so I have this quadratic function right here. I'm going to make a table of values and see if we can recognize anything. When x is 0, what is the y value, please? All you have to do is look at the graph. A little bit more. 3, good. When x is 1, what is the y value? 0, good. When x is 2, what is the y value? Good, -1. And then when x is 3, what's the y value? 0. And when x is 4, we're back up to 3. All right, so you want to try to look for a pattern. Can I add, subtract, multiply, or divide to go from 3 to 0? And can I do that same thing to go from 0 to -1? Can I do that same thing to go from -1 to 0? No, it is failing me. So to go from 3 to 0, you would have to subtract 3. And then here you would have to subtract 1. But then I would have to add 1. And then I would add 3. So I cannot find a pattern. But what I do see on the quadratic is symmetry. So anytime you're looking at a table of values and symmetry is the pattern that you notice, that means that you're going to have a quadratic function. All right, next page. So I have these 4 different table of values, and you have to figure out, is this linear or is this exponential? And so for all of these, it's all about what does the y value do? So when I go from 5 to 10, 10 to 15, 15 to 20, etc., etc., what is the pattern here? How do I go from one number to the next?
Add 5.
Add 5. If you are adding 5 each time, is addition, does that mean I have linear or exponential? Addition means that I have linear. So if you are going to add or subtract to get to the next number, you have linear. On number 2, okay, now I seem to be going down. That's okay. How do I go from 10 to 7? 7 to 4. 4 to negative 1. What is the pattern? How am I getting from one number to the next here? I am subtracting 3. So if I am subtracting 3, does that mean that this is a linear or an exponential? This is a linear function as well. So linear, it covers anything that is addition or subtraction to get to the next value. On number 3, so if I go from 3 to 6, you could add 3 to get there. But then if I want to go from 6 to 12 and I add 3, that's only 9. So that kind of failed me. So what else works? How can I get from 3 to 6 and 6 to 12 and 12 to 24? Multiply by 2. If you are going to multiply to get to the next number, what does that make this function? Linear or exponential? This makes this an exponential function. So exponential is when you are going to multiply or divide to get to the next value. What is 4? Linear, exponential, neither. So when you look at these y values, what do you see? What jumps out at you? Good. So I see symmetry as well. So I have this 4 right here, and then on either side of it I have a negative 3, and then on either side of that I have a 0. So I see symmetry here. If you see symmetry, that makes this a quadratic. All right, so now we're going to have some word problems. And we have to decide, is this a linear or an exponential function? So there will be no quadratic. We have to circle the correct response, and we have to write a formula. So to summarize what I had on the other side, you have, if you have a linear function, we're going to use y equals mx plus b. You will see phrases like I am adding something every time, or I am subtracting something every time. The m is going to be your rate, and the b is going to be your starting number. Some of the problems might be exponential. Exponential, your formula is y equals a times b to the x. You're going to be able to identify this because there is multiplication or division to get to the next value. If it's multiplication, it might use the phrase something doubled every hour, it tripled every hour. For division, it would probably say it was cut in half every hour. So if you see these phrases, these mean that you have an exponential function. Your A is going to be your starting amount, and the B is the rate or the multiplier. All right, so I wanted that handy when I read these word problems. So on number 1, a library has 8,000 books and is adding 500 more books each year. So I see 8,000 books. Does this seem like an initial amount or a rate it's going up by every time? This seems like your initial amount. It is adding 500 books every year. If we are adding, does that make this a linear or an exponential function? That makes that linear. Okay, so this is how much it's going up by. So this is your M, that's your rate. And since we have a linear, then my starting amount is my B in this case. So I'm using y equals mx plus b, and the M is 500, and the starting amount is 8,000. And so that is how I took the words and I ended up writing the equation. Number 6, a gym's customers must pay $50 for a membership plus $3 each time they go to the gym. All right, what words did you see? Do you think this is linear or exponential? This is definitely linear. What words did you read that said this is a linear function? It said plus $3 each time. That right there is your rate. It's going up $3 each time. So my $50 membership fee right there, that is my starting amount. So that right there is your B value. So therefore, this is y equals 3x plus 50. Number 7, a bank account starts with $10. Every month, the amount of money in the account is tripled. What word did you hear that said, is this linear or exponential? We hear the word tripled. If something triples, does that mean that you have a linear function or an exponential? That means you have an exponential function. And so when something is going to triple, that means it's going to go up by multiplication. And the amount it goes up, your rate or multiplier, that is your B value right there. A is your starting amount, and so it says that it starts with $10 every month. So that is your A. So the formula is y equals A times B to the x. So I'm going to sub 10 in there. Tripled is the equivalent of a 3. to the exponent. That's what that looks like. Number 8, there are 20,000 owls in the wild. Every decade, the number of owls is halved. Okay, so the amount is going down. Is it going down by a linear that makes it by subtraction that makes it a linear problem? Or is it going down by division, which makes this an exponential problem? If something is halved, this is division, so that makes this an exponential problem. That halved, that is your rate it's going down by. That means that is your B value. It says there are 20,000 owls in the wild. So that seems to be your A. That is your starting amount. So the formula is y equals A times B to the x. So I have 20,000. It is halved, and so you could either use the fraction 1/2 or you could have used the decimal 0.5. I don't care, either one is fine. I'm going to say one more thing. If you look at this, y equals 10 times 3 to the x, that is literally the problem. Do not ever tell me that that is 30 to the x. Otherwise, you are violating the order of operations. Order of operations say you have to do exponents, and then you have to multiply. Thank you so much, Algebra 2. I appreciate it.